In May of this year, instruments at the Mauna Loa Observatory in Hawaii recorded something that no human being who has ever lived has personally witnessed before. Atmospheric carbon dioxide hit 432 parts per million, and according to the 800,000-year ice core record scientists used to reconstruct the planet's ancient atmosphere, CO2 never once climbed past roughly 300 parts per million across that entire span. To find a time when the atmosphere held this much carbon dioxide, you have to go back roughly 3 million years, to the mid-Pliocene, a period so far removed from human existence that our own species, Homo sapiens, wouldn't evolve for another 2.5 million years or more. Every single person alive on Earth today is breathing air with a chemical composition that predates humanity itself. And that's only the headline number. Layered directly on top of it, scientists are now tracking the most powerful El Niño event potentially ever measured, arriving at the exact same moment the atmosphere is holding more water vapor than at any point in the modern instrumental record. Today, we're breaking down exactly what's actually happening to the atmosphere right now, why climate scientists are using words like unprecedented instead of their usual, more careful language, and why nearly everyone studying this agrees the most intense effects haven't even arrived yet. No exaggeration, just the current data and the actual science. If unusual weather has touched your life this year, tell me in the comments where you are. And subscribe now if you want to keep tracking this as it develops. Let's get into it. Let's start with the carbon dioxide number itself, because it's the foundational piece underlying everything else in the story. The Mauna Loa Observatory, operated by NOAA's Global Monitoring Laboratory, has maintained a continuous atmospheric CO2 record since 1959, the longest unbroken instrumental record of its kind anywhere on Earth. That record shows atmospheric CO2 climbing to 432 parts per million in May 2026, a new high in a dataset stretching back nearly 70 years. But the truly significant context comes from a separate, far older record, the roughly 800,000-year history scientists have reconstructed, from ice cores drilled in Antarctica and Greenland, where ancient air bubbles trapped in compressed snow layers preserve a direct physical sample of what the atmosphere actually contained thousands of centuries ago. Across that entire 800,000-year record, CO2 concentrations never climbed above approximately 300 parts per million, even during the warmest natural interglacial periods between ice ages. The last time the atmosphere held as much carbon dioxide as it does right now was roughly 3 million years ago, during the mid-Pliocene epoch, a period when global temperatures ran somewhere between 2.5 and 4 degrees Celsius warmer than today, and global sea levels set dramatically higher than they do now. It's worth being precise about what that comparison actually means, because the significance goes beyond simply a big number. The pace at which this concentration has climbed is itself part of the story. According to analysis of the Mauna Loa dataset, CO2 is now accumulating in the atmosphere roughly 3 times faster than it did back in the 1960s, meaning not only is the absolute concentration at a level unmatched in millions of years, the rate of increase itself has been steadily accelerating decade after decade, with each successive 10-year period adding carbon to the atmosphere faster than the decade before it. That acceleration matters because it's a direct measure of how quickly the fundamental chemistry of the planet's atmosphere is changing. Not a slow, centuries-long drift, but a compressed, historically unprecedented pace of change concentrated into a single human lifetime. The CO2 record isn't happening in isolation either, and this is where the story becomes genuinely more complex than a single headline number. According to the American Meteorological Society's 2024 State of the Climate Report, compiled with contributions from roughly 600 scientists worldwide, the global atmosphere contained the largest amount of water vapor ever recorded that year, with more than 1/5 of the entire planet registering its highest water vapor values on record. The same report documented that extreme rainfall, measured specifically as the annual maximum daily rainfall recorded over land areas worldwide, was the wettest on record as well. That combination matters mechanically because water vapor itself functions as a potent greenhouse gas, and a warmer atmosphere is physically capable of holding more of it, following a well-established physical relationship where atmospheric moisture holding capacity increases by roughly 7% for every 1 degree Celsius of warming. That means record CO2 levels and record atmospheric water vapor aren't two separate coincidental records. They're mechanically linked, with rising carbon dioxide driving warming that directly enables the atmosphere to hold more water vapor, which itself then adds further warming on top of the CO2 effect. A reinforcing cycle, rather than two unrelated coincidences arriving in the same year. Now layer the ocean into this picture, because the same 2024 State of the Climate Report documented that global ocean heat content, measured down to a depth of 2,000 meters, continued its long-term rise that year, extending a streak that a separate January 2026 report published in the journal Advances in Atmospheric Sciences confirmed had reached a new record for 9 consecutive years running. The ocean has absorbed more than 90% of the extra energy trapped by greenhouse gases over the past half-century, functioning as an enormous thermal reservoir that's been steadily accumulating heat for decades, even as that accumulation stays largely invisible to anyone not directly measuring it. Global sea level, driven both by that warming ocean water expanding and by melting ice sheets and glaciers adding new water into the ocean basin, hit a new high for the 13th consecutive year in the same report, sitting roughly 4 inches above the 1993 baseline researchers use as their modern reference point. Here's where this year specifically becomes its own distinct chapter in that longer story. In 2026, a genuinely powerful El Niño event developed in the tropical Pacific, officially declared by NOAA's Climate Prediction Center on June 11th. El Niño works by releasing heat that's been stored in the tropical Pacific Ocean directly into the atmosphere, temporarily boosting global average temperatures on top of whatever the underlying long-term warming trend is already doing. That's precisely why climate scientists have been watching this specific El Niño with unusual concern, because it isn't developing against a normal, stable baseline. It's developing directly on top of 9 consecutive years of record ocean heat content, record atmospheric water vapor, and the highest atmospheric CO2 concentration in roughly 3 million years. Daniel Swain, a climate scientist at UCLA and the California Institute for Water Resources, put the significance of that combination in genuinely stark terms, stating directly that in modern human history, we've never experienced a strong or very strong El Niño event arriving amid pre-existing global conditions this warm. That's not a casual observation. It's a direct statement from a working climate scientist that the specific combination of factors driving this year's weather has no precedent anywhere in the instrumental climate record. The practical effects of that combination showed up almost immediately once this year's El Niño began developing. World Weather Attribution, a climate research collaboration, warned in May that the emerging El Niño could contribute to what the organization described as an unprecedented year of global fire activity, with the global fire season already getting off to what one researcher, Theodore Keeping of Imperial College London, described as a very fast start, particularly across the African savanna, Southeast Asia, and northeastern China. Europe experienced an early and severe heat season as well, with Spain, Portugal, France, Germany, the United Kingdom, the Netherlands, and Hungary all breaking national or regional temperature records within weeks of each other, some records dating back to the 1800s. Barcelona recorded its hottest day in more than a century. The Netherlands, for the first time in its history, declared what it now formally classifies as a super heat wave on its own national heat scale, a threshold the country had never before needed to invoke. It's worth taking a moment to explain exactly how scientists reconstruct atmospheric conditions from millions of years ago with enough confidence to make a comparison this specific. Because the ice core methodology underlying the 3 million year claim deserves real scrutiny rather than blind acceptance. When snow falls in Antarctica or Greenland, it doesn't compact into solid ice immediately. It first passes through an intermediate, granular stage, trapping small pockets of the actual atmospheric air present at the moment that snow layer formed. As additional snow accumulates on top over subsequent years, that trapped air becomes permanently sealed inside tiny bubbles within the ice itself, preserved essentially unchanged as the ice sheet continues growing thicker over centuries and millennia. Drilling a vertical core through that ice and analyzing the composition of gas trapped in bubbles at different depths gives researchers a direct physical sample of the ancient atmosphere at each corresponding point in time, with deeper, older ice-yielding samples from further back in history. That's a fundamentally different, more direct kind of evidence than statistical estimation or computer modeling. It's literally measuring gas molecules that have been physically sealed away since the period being studied, which is exactly why the 800,000-year ice core record carries such strong scientific weight when compared against the modern instrumental measurements from Mauna Loa. It's also worth understanding why water vapor's role in this story matters as more than just a secondary detail, because the physical relationship between temperature and atmospheric moisture is one of the most well-established, quantitatively precise relationships in all of atmospheric science. The specific principle involved is known as the Clausius-Clapeyron relation, and it describes how the maximum amount of water vapor air can hold increases at a predictable exponential rate as temperature rises, roughly 7% more moisture holding capacity for every additional degree Celsius of warming. That's not a rough approximation. It's a well-tested physical law that shows up consistently across laboratory experiments and real-world atmospheric measurements alike. Applied at a planetary scale, that relationship means a warmer atmosphere doesn't just feel more humid in a vague, subjective sense. It is measurably, quantifiably capable of holding and transporting more actual water vapor, which is precisely why the AMS documented record water vapor content of 2024 tracks so closely alongside the same year's record ocean and atmospheric heat. They're not two coincidentally occurring records. They're two directly mathematically linked expressions of the same underlying warming. Here's the piece of this story that connects most directly to the title's second half: why the atmosphere's current state is genuinely far from finished playing out. Robert Rode, chief scientist at Berkeley Earth, an independent nonprofit research organization that produces its own closely watched global temperature analysis, stated in August that Berkeley Earth's own modeling now puts the odds at 69% that 2026 will surpass 2024 to become the hottest year ever recorded. But Rode was equally direct that regardless of how 2026 itself ultimately ranks, 2027 is already expected to set a new record on top of it. In his own words, describing what's coming, we are likely to see something quite dramatic in the next year or so. Weather conditions that would normally be expected roughly a decade or more into the future, arriving instead within the next 12 to 18 months. That statement reflects a well-established, consistently observed pattern in how El Niño actually affects global temperatures. The warming boost El Niño provides to the planet's average temperature doesn't peak at the same moment the oceanic event itself peaks. It lags behind by roughly 6 months, meaning since this year's El Niño is forecast to reach its own peak intensity sometime between September and November 2026, the single strongest influence on global average temperature from this specific event likely won't actually arrive until sometime in early to mid-2027, months after most casual observers will have stopped paying close attention to it. That lag effect isn't a new or speculative pattern either. It's been documented across every major El Niño event in the modern climate record. The 2015-2016 El Niño followed the identical arc, with 2016 ultimately becoming the record warm year, rather than 2015 when the event itself was actually developing. The same pattern played out again with the 2023-2024 event, where 2024, not 2023, ended up setting the global temperature record. Based on that consistent historical relationship, and given how this year's El Niño is already tracking as one of the most powerful on record, arriving on top of already unprecedented baseline conditions across CO2, water vapor, and ocean heat simultaneously, the expectation that 2027 could exceed whatever record 2026 itself sets isn't speculative alarmism. It's simply the same well-established physical pattern playing out again, on top of a genuinely higher, more extreme starting baseline than any previous instance of this pattern has ever occurred against. It's worth understanding exactly how confident scientists actually are in numbers like these, because a claim this significant deserves real scrutiny of the underlying methodology. The UK's Met Office, one of the world's leading national meteorological agencies, produces its own independent seasonal and annual global temperature forecast, and its most recent projection places 2026's global average temperature between 1.34 and 1.58 degrees Celsius, above the pre-industrial baseline, with a central estimate of 1.46 degrees. Professor Adam Scaife, who led that specific forecast, noted that this would mark the fourth consecutive year the planet has run above the 1.4 degree threshold, a streak with no precedent in the instrumental record. Met Office scientist Dr. Nick Dunstone described the broader significance directly, stating that this trajectory highlights how rapidly the world is now approaching the 1.5 degrees Celsius threshold established as a target under the Paris Agreement, a number that has functioned for years as a widely cited symbolic marker of significant accelerating climate risk. It's worth noting that this Met Office projection was produced entirely independently from Berkeley Earth's own analysis, using different underlying data processing methods and a different forecasting approach, yet arriving at a broadly consistent conclusion, further reinforcing the strength of the overall pattern rather than resting on any single organization's specific methodology. It's also worth being genuinely careful and precise about what all of these unprecedented readings do and don't mean for any single day's weather anywhere specific. None of this data allows anyone to predict exactly what temperature a given city will experience on a given day next month, and normal, everyday weather variability, a cool front here, a rainy week there, continues operating within this broader pattern rather than being replaced by it entirely. What this data does represent is a shift in the underlying baseline conditions that all future weather operates on top of, meaning the same weather-generating mechanisms that have always produced heat waves, droughts, floods, and storms are now operating against a backdrop of record atmospheric CO2, record water vapor, and record ocean heat simultaneously, a combination that tends to push individual weather events toward more extreme outcomes than the identical underlying weather pattern would have produced against an earlier, less loaded atmospheric baseline. It's a useful analogy to think of the atmosphere the way you'd think of a boxer stepping into the ring, already fatigued from a hard training camp. The same punch that might have been absorbed easily under normal conditions can produce a very different outcome once the underlying baseline has shifted, even though the punch itself, the individual weather event, looks superficially similar to ones that have occurred before. There's also a specific reason scientists have started reaching for words like unprecedented rather than their usual, considerably more careful and hedged scientific language. And it's worth taking that linguistic shift seriously rather than dismissing it as media hype. Climate scientists as a professional community are generally trained toward caution, qualifying claims, citing confidence intervals, and avoiding language that could be interpreted as alarmist beyond what the actual data supports. When researchers at organizations including Berkeley Earth, the UK Met Office, and World Weather Attribution independently start using words like unprecedented, dramatic, and words describing conditions with no known analog in the historical record, that consistency across multiple methodologically independent research groups represents a meaningful signal in itself, distinct from any single researcher's individual assessment or any one organization's particular modeling approach. It's also worth noting that this kind of cautious professional community shifting its own language represents a meaningfully different kind of evidence than a single dramatic headline or a single alarming chart, because it reflects a broad, cross-institutional consensus forming around genuinely unusual conditions rather than any one group's particular interpretation or communication style. So what should you actually take away from this genuinely unusual moment in the planet's atmospheric history? First, understand that the core numbers driving this story, atmospheric CO2 at its highest level in roughly 3 million years, record atmospheric water vapor, 9 consecutive years of record ocean heat content, and one of the most powerful El Niño events ever measured arriving directly on top of all of it, are independently verified, methodologically distinct measurements converging on the same broad conclusion, rather than a single alarming data point being amplified out of proportion. Second, understand that the well-documented 6-month lag between an El Niño's peak and its full effect on global average temperature means the most intense expression of this year's specific combination of factors likely hasn't arrived yet, with 2027 widely expected among researchers to represent the year this pattern's effects become most fully apparent. And third, understand that none of this changes day-to-day life in a way that requires panic or a fundamental change in how anyone goes about an ordinary week. But it does mean that extreme weather events, heat waves, wildfires, and heavy rainfall events alike, are now unfolding against a genuinely different, more extreme atmospheric baseline than existed even a decade ago. A baseline worth understanding clearly rather than dismissing as ordinary summer weather. Understanding that distinction between an unusual and well-documented shift in the planet's baseline conditions and an exaggerated claim of imminent day-to-day catastrophe is exactly what separates genuinely informed awareness from either dismissiveness on one side or unwarranted panic on the other. It's also worth understanding what actually happens to that record ocean heat once it's been absorbed, because the ocean isn't simply a passive storage tank that holds heat indefinitely without consequence. Warmer surface water expands physically, taking up more volume than the same mass of cooler water, which is one of the 2 primary drivers behind the rising global sea levels documented in the 2024 State of the Climate Report. It also fundamentally changes conditions for marine ecosystems, contributing to coral bleaching events, shifting the distribution of fish populations that coastal economies depend on, and providing additional energy that can fuel more intense tropical cyclones once they form over unusually warm ocean water. That's precisely why 9 consecutive years of record ocean heat content represents more than an abstract statistic buried in a scientific report. It's a physical reservoir of stored energy that continues expressing itself through sea level rise, marine ecosystem stress, and storm intensity, largely independent of whatever the atmosphere itself happens to be doing in any single year. We will keep tracking this story as new climate data continues coming in through the rest of this year and into 2027, particularly as this year's El Niño approaches its own peak later this fall and its full delayed effect on global temperatures becomes clearer over the following months. If this gave you a clearer picture of what's actually happening to the atmosphere right now, subscribe so you don't miss the next update and drop a comment letting me know what unusual weather has looked like where you live this year. Stay curious, stay informed, and I'll see you in the next one.